Well, good evening, everyone. We have some vocabulary to look at. We're going to be starting with the word point. Now, point, line, and plane are three vocabulary words in geometry that technically don't have a definition, but instead are ideas. They're ideas that we say and can talk about in geometry that technically exist, but not really. And here's why. So when we talk about a point, we're talking about this spot right here. Boom. That's a point. Now, in reality, I actually drew something that was larger than a point. A point is something that has no size and no dimension. So a point is something with no size or dimension. So what that really means is we're talking about the 0th dimension. So 0D. So another way to talk about that is that a point is a location. And so the point that I talked about up here, while we draw it by using the width of our pencil lead at the tip of our pencil and draw that down, that's how we represent it, but we're not actually drawing a point because we're always drawing something that's too big. And everything we talk about, everything that exists in our real natural world is always larger than a point. So you think about molecules and atoms and Planck lengths and keep going as small and small and small as you can. We're always existing in the third dimension because there's always something there, some space and some area and volume, and a point has none of those things. A point is in that 0th dimension like we talked about, so it has no space. So that's a point. Now, in geometry and in mathematics, we can name these points so we can refer to them easily and talk to one another so we know what we're talking about. If you want to name a point in mathematics, we name points with just letters. So if you want to name a point, we don't name them with arrows or fun things like that. We instead name them with more fun things, like the letter A. And we always use capital letters to name points. So we name points with capital letters. And that's how we're able to refer to it and talk about it and refer and deal and work with them. And so we talk about them with capital letters, and you can use any capital letter you want. But if it's a capital letter, when I look at that, I know you're referencing to a point. Where that takes us next is talking about a line. A line, if the point is 0 dimensions, the line is 1 dimension. And so you can imagine that a line, like we've talked about before, like you've seen before, is just a straight line like that. So you might have noticed that my line changed just a little bit. It is now truly much straighter. So when we talk about a line, the hard part with a line is even though it exists in the first dimension, what that really means is we can only travel in one direction, not the band, but talking about the movement. And so we can either go left or right. That's the one direction we can go with, side to side. So that's why it's the first dimension. Now, since we can go side to side, and we talking about this line, we can call the whole line generally with a lowercase cursive letter. And the letters that are generally reserved for a line, like X and Y are reserved for equations, is generally we can call the line L, M, or N. And so those 3 letters are generally reserved for lines, but there's another way we can name and talk about lines here. And that's using a fun fact about lines, and that is that a line actually is created by an infinite number of points drawn side by side over and over and over again. And so I'm just drawing points and points and points and points side by side over and over and over again. But the hard part is that all those points that I've drawn are all too far apart. Like we've talked about with the definition of a point, there is no size or dimension, which means when we draw a point, we can never draw another point close enough for them to actually touch. If there is no size, a point can never touch another point because they're only talking about the location and they're not talking about any actual space around it. So when we say that a line is made up of points drawn side by side by side, what we're really saying is that there's an infinite number of points creating this line. And when we want to name a line, all we do is we emphasize the points that are already there. So let's call this point that I drew earlier, point A. Let's call this point over here that I drew earlier, point B. If I wanted to talk about this line, I could use L, M, and N, or I could talk about line AB. Now, if we're talking about line AB, I'll go ahead and use green here to help illustrate it. If we're talking about line AB, we're only talking about the portion of the line right here. That's line AB. So here, actually, I'll go ahead and make this part in green. So, line AB. Now, when I talk about that, we're talking about it ending at A and ending at B. So that is a line segment. When we're being really official and really careful with our language, if we want the line to end at A and B, that's a line segment, not a full line. Because a full line in black includes the arrows because it's going on forever for the left and from the right. And so that's line AB with the arrows. So we just call that a general line. Now, let's say it goes in one direction and not the other. So let's say it's going from A through B and all the way over to the other side here, like I drew in red. Well, we would call that a ray. And so we draw the arrow just over the part that's going on forever. So the arrow is over B, and that's a ray. Now, we can write the letters in any order we want. It doesn't have to be that the A is first and the B is second, but in order to match our line in red here, that has the arrow going off towards B, the arrow has to be over B. So this same ray can also be called BA as long as the arrow is over the B. The arrow has to be over B if the line is continuing forever off the side of B. And so those are the three different types of lines. A line segment ends on both sides. A line continues off forever in both directions, and a ray has an arrow over one side or the other. This is why we like naming them by points. This is why we like using the tool letters at the same time, because it's an easy way to track what sort of line we're looking at. When we just use the actual lowercase letters to name a line, we wouldn't talk about ray L, because L, M, and N just refer to full lines, not line segments and not rays. So I hope that helps, and I hope that gives you some insight on lines. All right, you guys, let's talk about a plane. Not the kind of plane in the air, but the kind of plane that exists in mathematics, although they are spelt the same. So a plane is described as being in the second dimension. And so like a point, I'll just refer back up here, like a bunch of points being lined up over and over again to make a line, pun intended. You can have an infinite number of points to help create that line. A plane is made by an infinite number of lines being layered. So imagine that you draw a line and then another line and then another line and then another line and then another and another and another and another, and you keep doing that forever, an infinite number of times. What you end up getting is kind of a layer like you would with some paper. And so when you have paper that's being layered over and over and over again, I'll use this wonderful textbook right here. When you are layering your paper over and over, you can imagine each of those as lines to create a plane. And that's just this flat surface right here in front. And so that's where you're able to get that second dimension from. And so you layer all those lines, you end up getting a plane like you would from a sheet of paper. Now, here's where you have to practice your art skills. If you're going to draw a plane, you're drawing a flat surface on a flat surface. So in order to help us differentiate and distinguish and practice looking at planes, what we do is we imagine taking that flat surface and we imagine angling it away. So notice on how the top looks shorter than the bottom. It looks like that it's longer. And then if I twist it just a little bit, now here's this flat surface and we have the top and the bottom, and we can talk about things that happen on this flat surface. And so here I've drawn this flat surface, and we can talk about points that end up on this flat surface. We can talk about lines that end up on this flat surface. We can talk about shapes like squares and triangles and circles and things, because it's a flat surface like a piece of paper that we're able to work off of. So like I said earlier, a plane is in the second dimension. And if we were trying to describe a plane, it is a thing with height and width, or height and depth, no depth, just height and width, but no depth. So it is completely flat. It has no depth, just those two directions, up and down and left and right. And so we can describe a plane as an infinite number of lines, or by extension, an infinite number of points that extends without end in two directions. And the key piece here is that there's an infinite number of points on a plane, just like there's an infinite number of points on a line, just like a point that has no area, volume, space whatsoever. It's just a location. Hey, thank you guys. I hope that gives you a good idea about points, lines, and planes. If you have any questions, don't hesitate to ask.